Bismillahirrahmanirrahim. Welcome to the second part of this topic, which is Introduction to Functions. The first part, we gave the definition of the function as the set of ordered pairs in which no two ordered pairs have the same first coordinate and different second coordinate. In this part, we are going to speak about the domain and range of the function. As we said that for the function, it is a set of ordered pairs. The domain of the function is the set of all the first coordinate of the ordered pairs. It is the set of all ordered pairs. For example, if I have set of ordered pairs 1, 2, 3, 4, 5, 6, 7, 8, this is set of ordered pairs. And since all the first coordinates are different, then this is a function. If we take the set of all the x coordinate, only the first coordinate, 1, 3, 5, and 7, we call this is the domain of the function. So the domain, I'll use capital D, is the set of the x coordinates of the function. First of all, we are speaking about a function. So a function is a set of ordered pairs where there is no repetition in the first coordinate, or there is no two ordered pairs have the same x coordinate. Since all of them are different, this is a function. If we take the first coordinate, that are 1, 3, 5, and 7, we call this is the domain of the function. Now the second coordinate of the function, we call the range. It is range. So the second coordinate, different color here, 2, 4, 6, and 8. This will give me the range of the function. Range R equal to 2, 4, 6, and 8. So the domain is the first coordinate of the ordered pairs, and the range will give me by, or will be represented by the second coordinate or the y coordinate. Now, if the function is defined by an equation, sometimes we are writing the function as y equal to x minus 1. This is a function given by an equation. Then the variable that represents element of the domain, which is, as we said, it is the x coordinate. So I have y equal to x minus 1. Then I will call that the domain, or the variable that represents the domain is the independent variable. We call it independent variable. So it is x in my function. X is independent variable. Independent means I can give x any value. I can choose or substitute x by any value. But y, I cannot choose it. That will be given directly from the equation. And that's why we call the x is the independent variable. Independent variable, and y, we call it dependent variable. And in general, the function can be written using different notations. Usually, we can use the letter f of x, g of x, h of x. These are notation for the function, and x will give me the independent variable. Or I can use any variable, I can say f of t or g of t time, for example, and h of t. X or t will give me the independent variable. And the function can be written in different forms, either it will be polynomial function or fractional function or what's called a piecewise function or piecewise defined function. The piecewise defined functions are functions given in this form. F of x, it is like different pieces, depend on the different domains of the function. So f of x equal to x plus 1 when x is less than minus 2, or x squared minus 1 when minus 2 is less than or equal to x less than or equal to 3, and it's equal to 4 minus x when x is greater than 3. We call this type of function piecewise functions. So these are functions that are represented by more than one expression. These are piecewise defined functions. And the domain for the function, whether it is written as a set of ordered pairs or in the function notation, can say in general, unless otherwise stated, the domain of a function is the set of all real numbers for which the function makes sense. It means that it can give me a value. When I replace x by or replace the independent variable by any value, I will have a real number. So these values of x will give me the domain of the function. And unless it is stated, the domain of the function will be all the real numbers from minus infinity to plus infinity. And in general, this is given for the polynomial functions. If we have linear function or quadratic or any polynomial function, the domain for the polynomial function will be from minus infinity to plus infinity, or we can say it is all the real numbers. For example, I need to find the domain of the function represented by the given equation. The first one, I have f of x equal to minus 2x plus 1. Actually, this is polynomial form. Any function in this form or in the polynomial, either linear or non-linear, the domain will be equal to all the real number. These are means real numbers. I can say it is all real numbers. It is R, capital R in this notation, or I can say from minus infinity to plus infinity. The domain for this function will be from minus infinity to plus infinity, or I can say it is just the all real numbers. For the second function, f of x equal to 3x squared plus 1, again, this is polynomial form or polynomial function. So the domain again will be equal the same, minus infinity to plus infinity, or it's equal to all the real numbers. Any functions given as a polynomial function, polynomial, then its domain is from minus infinity to plus infinity, or it is the all real numbers. For the third one, I have f of x equal to 6 over x minus 5. This is not a polynomial. It is a rational function, or I can say fractional function. 6 divided by x minus 5. For this type of functions, all what we need to find the zeros of the denominator. So I have to say for this function that x minus 5 is not equal to 0, which means x is not equal to 5. This is the domain. It is all the real number except the number 5. Sometimes we can write it in this form. D is equal to all the real number except the number 5. Means number 5 is not included or excluded from the set. So the domain will be the whole real numbers except the zeros of the denominator, which is 5 in this case. Any fractional function. To find the domain, we have to find the zeros of the denominator and excluded from the real numbers. For the fourth example, I have f of x equal to square root of 4 minus x. We know that for the square root, what is inside must be greater than or equal to 0, because the square root of negative numbers will be complex, and these are not real values. So to find the domain of the square root, 4 minus x, to find the domain, we have to say 4 minus x must be greater than or equal to 0. Then I have linear inequality. Just to solve it, I will have x greater than or equal to 4. So the domain in this case will be from 4 to infinity, closed 4 to infinity. So for the square root, what is inside square root must be greater than or equal to 0 if it is not in the denominator. So that's the domain for this function will be from 4 to infinity. Question number 35. I need to find the domain for square root of 4 minus x squared. Again, what is inside to find the domain is 35. 4 minus x squared greater than or equal to 0. But this is nonlinear inequality. So we have to apply the critical value method to find the solution for this polynomial. So all what I need to find the critical values as we did before in the topic of the inequalities. So this one, I need to find the critical values. Step number 1, critical values, that is 4 minus x squared equal to 0. So this can be by factoring, it is 2 minus x multiplied by 2 plus x equal to 0. I will have x equal to 2 or x equal to minus 2. These are the critical values. Second step, as we did before, check the sign. I have minus 2 and I have 2. We choose values less than minus 2, it is minus 3. Between minus 2 and 2, I will choose 0. Greater than 2, I can take 3. And I have 4 minus x squared. Now, if we replace x by minus 3, 4 minus 9 is minus 5, I will have negative sign. If I choose 0, I will have, as we just replace x by minus 3 or replace it by 0, I will have 4, which is positive. If it is 3, I will have negative. And since we are looking for value greater than 0, we have to take the positive. So we can say the domain for this function is between minus 2 and 2. Because I have quality there. So the domain for this function is between minus 2 and 2, closed interval. For the last one, I have f of x equal to 1 divided by square root of x plus 4. Now, since the square root is in the denominator, so we have to say x plus 4. We said before it should be greater than or equal to 0, but since it is in the denominator, it is down, then we have to exclude the equality. It is not greater than or equal, it is just greater than 0 because we cannot divide by 0. So if it is in the denominator, we have to say greater than 0, not greater than or equal to 0. Now this is linear inequality. will give me x greater than minus 4. So the domain for this function will be open minus 4 to infinity because it is greater than. Okay, this is the graph for this one is open minus 4 to the left. So the domain for this function is from minus 4 to infinity. So again, if we have polynomial function, the domain will be from minus infinity to plus infinity, or the real numbers. If we have fractional function, numerator and denominator, we have to find the zeros of the denominator and exclude it, take it out from the real numbers. We say the domain will be all the real numbers except the zeros of the denominator. If we have square root, then the domain will be taking what is inside the square root, make it greater than or equal to 0, solve the inequality and find the domain. If the square root is in the denominator, then we don't have equality. We don't have greater than or equal. It must be greater than only, greater than 0. That will give me inequality. Solve it, find the solution for the inequality. That will be the domain of the function. So this is how to find the domain of the function.